All right, seventh graders, moving on with equations. I need you to have page 26 in front of you, and I need your brains to be ready to think about this a little different way than we did yesterday. All right, page 26 looks like this. Pens, pencils in hand, and here we go. This page is called Solving Equations. We are absolutely still working with that E, that second E of our EE strand. But notice it now says multiplication and division. We've already learned in this class that we should have two separate boxes, drawers, whatever in our brains. One that's filled with addition and subtraction stuff, and one that's filled with multiplying and dividing stuff, because the two work differently. And if we can get in our heads how differently these two work, it'll make a lot of this mathematics easier for us. Let's start right here with the fill in the blanks. To undo multiplication and an equation. This is talking about more inverse operations. We dealt all yesterday with the additive inverse. This is going to be something different. In fact, it's going to be one of my favorite things to say. It's one of my favorite words, and I'll share it with you in just a second. I've said it in class before, but to undo multiplication in an equation, you, of course, divide, because multiplying and dividing are inverse operations. To undo division in an equation, you multiply. To undo multiplication, you divide. To undo division, you multiply. This means that just like addition and subtraction, multiplication and division are, oh look, I wrote it up there, and I'm going to write it again right here. Inverse operations. Okay, now what that means is that they are going to help us isolate the variable. But before we actually get to how, let's pause for a minute and do this little interim thing. Right here, let's look at these instructions. You might see where my finger is. Find the variable in each equation. That's where we look at and say, is it on the Adeline side or the Penelope side? Determine if the number with the variable is being added, subtracted, multiplied, or divided on the variable. In other words, what are they doing to the variable? Look at these big capital letters. Only look at the side with the variable. Focus on the side with the variable. Ignore the other side right now. Then determine how you would cancel out the number with the variable. All right, so notice these instructions did not say solve the equation. This is a little in-between step. We'll get to that. But what I want you to write out and really focus on here, I'm going to show you the first three. I'm going to model for you how I want you to do this, okay? So look at number one. Ask yourself, where is the variable? Okay, you can draw this if it helps you. You can see really clearly that the variable is on the Adeline side. The next question is, what are they doing to the variable? What does this bar mean? Oh, they're dividing by 10. Okay, what are they doing to the variable? They're dividing by 10. So then the next question is, what are you going to do to cancel it? What are you going to do to isolate the variable? And I don't actually want you to do it right now and write an answer. I don't want you to solve this. I want you to tell me what you would do. So let me model that for you on this one. I would say on this one, if they're dividing by 10, I'm going to multiply both sides by 10. And that's the statement I want you to write. We'll practice actually doing that in a minute, but right now I just want you to verbalize and really wrap your head around, what are they doing to the variable? Okay, because they're doing that, I'm gonna do this. Let's try it again. Number two. Look what I see here. I see the Adeline side and the Penelope side. Okay, what are they doing to the variable? It's over here on the Adeline side. What are they doing to it? What does that 3x mean? Mathematically, oh, that means multiply. They are multiplying by 3. So if they are multiplying by 3, what are you going to do? You are, of course, going to divide both sides by what? Well, what's the number with the variable? 3. You're just writing down for me the actual action that you're going to take. What's the inverse operation that you would do? Let's try one more together. Okay, here's number 3. The variable's over here on the Adeline side. What are they doing to the variable? They are adding 3. So if they are adding 3, what are you going to do? You're going to do the inverse operation, and you are going to subtract 3 from both sides. This is where I get the question, do I really have to write from both sides on all of them, Miss McGowan? Yes, yes you do. Because if you write it down on every single one of these, then it will be stuck in your brain forever. That whatever you do to one side, you always have to do to the other side. Now, I'm gonna ask you guys to do something right now, and I need you to actually do it. What is that thing I'm gonna ask you to do? Pause me. When you pause me, I want you to go through this process. I've done the first 3 for you. I want you to go through that exact process on 4 through 12, just through number 12. Which one are we going to? Number 12, okay? So I want you to look at where's the variable, what are they doing to the variable, and then I want you to write down how you would cancel that. Because they're adding 3, I'm going to subtract 3 from both sides, okay? Pause me right now and try through number 12. Okay, let's see how we did. So here is the next row. In my experience doing this in class when I let students try it, most students do okay with these 3, so check those out. What are they doing to the variable? They're subtracting 10, so what are you gonna do? Add 10 to both sides. What are they doing to the variable on this one? They are dividing by 8, so what are you gonna do? You are going to multiply by 8 on both sides. What are they doing to the variable on this one? They are multiplying by 8, so what are you going to do? You are going to divide both sides by 8. This is all about whatever they're doing, you need to do the inverse operation. And when I say what are they, whoever this they is, it's just whoever wrote this original equation, okay? So let's look at the next row. See how you did here. Number 7, what are they doing? In the equation, they are adding 8 to the variable, so what are you going to do? The inverse of that, subtract 8 from both sides. Sometimes number 9 throws people a little bit. Check number 8, add 8 to both sides. Number 9 throws people because, ooh, the variable is now on the Penelope side. Doesn't matter. Focus on the side with the variable. That's what matters. So when you look at this, you have no reason to get rid of that -3 because it's not with the variable. So now we're going to focus on the Penelope side. What are they doing to the variable? They're adding a +4. So what are you going to do? Subtract that 4 from both sides. Okay, let's look at the last row because in my experience with this one, the last row is sometimes where we make mistakes. So let's look at these. We're actually just going to look one question at a time to make sure we avoided these mistakes, starting with number 10. This one's interesting because I'll often get students in class that tell me something different, and just because you wrote something different, don't frantically scribble it out. It might actually be the same thing. I said add 4 to both sides because if you remember yesterday, we talked a lot about changing it to 0. Whatever is with the variable's over here on the Penelope side. Whatever's with the variable, I need to turn it to 0, right? Which is really what the inverse operation is about. That's what an additive inverse is it turns something to 0. So I said I would just do +4 + 4. I would add 4 to both sides. That is the quickest, most efficient way. But I'm going to tell you, if you looked at this and went, okay, what are they doing? They're adding a -4. So you said, I'm going to subtract a -4. Is that actually okay? Is that the same thing? Well, watch this. If you said, I'm going to subtract a -4, wait a second. What happens when you subtract a negative? You're really adding a 4. So if you said subtract a -4, you're correct. That is the exact same mathematics that would do it. It's just maybe a little bit more complicated and convoluted to worry about subtracting a negative instead of just adding 4. And if you just focus on what will turn it into 0, then you'll get there. Okay, number 11, take a look at what you wrote. There's a common mistake that happens on number 11 as well. And I want to make sure we didn't make that mistake on this one. So over here, if you said subtract -4, you were okay. On this one, if you said divide both sides by 4, you are not going to fully cancel it. And if you're not sure why, you will be by the time this page 26 is done. So if you said divide both sides by 4, you need to fix that right now because you actually need to divide both sides by -4 because what are they doing to the variable? Well, they're multiplying by a -4, and the inverse of that is dividing by a -4. And I know that can be confusing because we do the opposite, like this said -8, so we added 8. Well, that's an additive inverse, but that's not a multiplicative inverse. There's my favorite word. Multiplicative inverse. Try saying it, it just rolls off the tongue. Multiplicative. Go ahead, try. Multiplicative. It's a fun word. But we'll make sure we understand all about the multiplicative inverse. And then the last one, Also, on number 12, if they're dividing by -4, then you should multiply both sides by -4. -4, that's got to be there. So fix that if you don't have a -4. If you're not sure why, let's look at the rest of this and let's figure out why. Let's make sure we understand why. First of all, we have some properties of equality, just like we do with adding and subtracting. These, again, are just another way of telling us that whatever you do to one side, you also have to do to the other side. So right here, multiplication property of equality. If A equals B, if you start with an equation, this is saying the same stuff we wrote down yesterday. It's just got multiplication now instead of addition and subtraction. This is still saying whatever you do to the Adeline side, you absolutely have to do to the Penelope side. If I multiply this side by some number we'll call C, I need to multiply this side by the exact same number, which is why it's still called C. The division property of equality, as you guessed probably by now, is very similar. It starts like this, if A equals B, but look at how I wrote the division. I wrote it in a very secondary way, a way we really want to get used to writing our division. It looks like a fraction because that's ultimately what a fraction is it's a setting up division. But again, these two are just telling me, even with multiply and divide, if I do something to one side of the equation, I absolutely need to do that same something to the other side of the equation. Okay, let's put all of this together and let's practice solving some equations that involve multiplication and division. Some of these, in fact, are some equations from up here, not all of them. But let's look at these really closely and let's be really careful and help ourselves avoid some of the mistakes that are made with equations. Now you start the same way. You start with, where's the variable? Over here on the Adeline side. What are they doing to the variable? They're dividing by 10. So if they're dividing by 10, what are you going to do? You are, of course, going to multiply by 10. I'm going to tell you right now, I'm very picky about how you write this inverse step, and I'll say this again in your little help video for your Canvas quiz today. I am very picky about how you write this step because I really, really need you to show that it's doing the correct inverse operation. What do I mean by that? Well, before we write anything, let's come over here on the side and let's tell ourselves now, we are no longer working with an additive inverse. I shouldn't say no longer because of course we still will. Today, we're not working with an additive inverse. We are working with a multiplicative inverse. And that is different. A multiplicative inverse will not change something to 0. For example, if I have the number -3, the multiplicative inverse of that is -1/3. It's reciprocal, but ultimately what's going on with the multiplicative inverse, what's happening there, and this is not the first time we've talked about a multiplicative inverse. This is not the first time you've heard me say it. It's one of my favorite words. We talked about it with division because all of division turns into multiplying the multiplicative inverse, right? But what makes something a multiplicative inverse is that if you multiply it, you get the answer 1, not 0. You're not trying to turn things into 0 today. That's an additive inverse thing. That worked really well yesterday when we were adding and subtracting. Today, we're not worried about the additive inverse. We are worried about the multiplicative inverse. So today, are you listening? Are you listening? This is really important. Today, we want to turn things into 1. Yesterday, we turned the number with the variable into 0. Today, we need to turn the number with the variable into a 1. So here's how we do that. If this is dividing by 10, that's a lot like 1/10. And the multiplicative inverse would be 10. So watch what I'm going to do. I'm going to put times here, but I'm not going to put times 10 down here. No. That would be 10 times 10 and make 100. That's not what I want. I don't want to times 10 on the bottom. I need to times 10 on the top. Now, before I do anything else, I need to go, oh yeah, if I just multiply the Adeline side by something, then I definitely need to multiply the Penelope side by something too, that exact same something. This green number I write over here needs to still be the exact same green number with the same operation over here. Same thing happening to both sides. Now, what happened here is 10 divided by 10 equals 1. That's what I wanted because I want to be left with 1x. Now, if I tried to turn this into 0 right now with multiplying and dividing, if I made that a 0, I would have 0 times x, which would also turn my x into 0, which is no good. That's not what I want. I don't want to make the x go away. I just want to isolate it. So I need 1x. Today you are turning things into 1. Say that to yourself. What are you turning things into? 1. And do the math on the Penelope side. Negative 6 times 10, different signs negative, 60. So I solved this. I'm also going to do like we did yesterday. It says check your solution. I'm going to write that down in the corner here. What I'm saying is that negative 60 divided by 10, that's from the original equation, is equal to negative 6. True. It absolutely is. Let's try this again. Look at number 14. Okay, again, find the side with the variable. See it over there on the Adeline side? What are they doing to the variable? They are multiplying by 6. If they are multiplying by 6, what are you going to do? You are going to divide by 6. Your goal is to turn it into 1. Multiplicative inverse. When you are multiplying and dividing, you need to turn the number with the variable into 1. You just did something to the Adeline side, so you absolutely need to come over here and do that same thing to the Penelope side. See that? Same green number, same green operation, same exact thing happening to both sides of the equation. Look what I did here though. 6 divided by 6 is 1. That's exactly what I needed to happen so that I could get 1y and isolate the variable. Do the math on the Penelope side. 42 divided by 6 is 7. I solved it. Now I'm going to check it. Here's my original equation. What I'm saying is 6 times 7 is equal to 42. Yes, of course it is. Could you have maybe guessed that one without the inverse operation? Yes, but as we've discussed many times now the last couple of days, trust Miss McGowan, show this inverse step every time because these equations will start to get harder just in the next couple of days. But you won't feel like they're harder if you're showing these inverse operations. You will be ready. Whoa, 15. Okay, 15 gets a little weird. First of all, find the side with the variable. Okay, I see it over here on the Penelope side. What are they doing to the variable? I'm going to tell you right now, one of the very common mistakes I see students make is I see this over and over again. They write plus 15. You just really want to write plus 15. Now, let me just ask you guys, if I wrote plus 15 right there, can you even add those together? No, you can't, because one has an x and one wouldn't. That wouldn't even make any sense mathematically. It doesn't make any sense to write plus 15 there. That's not going to cancel anything. All it's going to do is add a constant term when I have a variable term here. This is being multiplied by negative 15. So I'm going to say that again. What are they doing to the variable? Multiplying it by negative 15. So if they are multiplying by negative 15, what are you going to do? You are going to divide by negative 15. Why is it so important here that you divide by negative 15? Well, back here we talked about what are we trying to turn it into? We are trying to turn it into 1, not negative 1. And if I just did 15, I'd turn it into negative 1x, and then I'd have to divide that negative 1 off anyway because I don't want to know what negative 1x is. I want to know what x is. So I'm going to divide by negative 15. I just did something to the Penelope side. I need to make sure I also do this to the Adeline side. Same exact number, same exact operation happening on both sides. This now divides to 1, which is exactly what I wanted, isolating the variable, 1x. Do the math here. You can type it in a calculator if you need to. Different signs negative. 75 divided by negative 15 is negative 5. And I'm just going to switch it around because I like to write my equations this way. Hopefully you noticed yesterday, always type your equations in Canvas with the variable first so that you don't get it marked wrong for that. And let's plug it in and check it. 75 equals negative 15 times negative 5. Is that true? Yes, because a negative times a negative takes me back to a positive. You can also start to see as all the negatives get involved how some of these would be really tricky to do in our heads because we tend to mess up the signs if we don't lay it out for ourselves with the inverse operation. Show the inverse operation. Show it. Here we go. I'm going to take you through a think aloud on these last 3, and then you're going to try some on your Canvas quiz today. There's another video. You'll get out a piece of paper and I'll help you with the first few, so don't worry. Here's the side with the variable. What are they doing to the variable? I see they are dividing by 2. If they're dividing by 2, what am I going to do? I'm going to times by 2, and I'm going to write it on the top because my brain now knows I'm trying to turn it to 1, and that only happens if 1's on the top and 1's on the bottom. I just did something to the Adeline side. I need to make sure I also do that to the Penelope side. 2 divided by 2 turns into 1, which is exactly what I wanted. 0.75 times 2, think of it like 75 cents times 2, it's $1.50 or 1.5. Let's check our answer. Is 1.5 divided by 2 equal to 0.75? Yes, it is. Number 17. You can, of course, always pause if you need extra time to write something down. Here's the variable over here on the Penelope side. What are they doing to the variable? They're dividing by 3.5. So I am going to times. You can put a little x if the dot and the decimal throws you off. I'm going to times by 3.5. And if I just did that to the Penelope side, I need to, you can also use parentheses for that, multiplication. I need to do the same exact math on the Adeline side. This turns into 1, which is exactly what I wanted. This, I can either do it out by hand or I can use a calculator. As long as you've shown this inverse step right here, then you know exactly what to type in a calculator and you don't confuse yourself. 3.5 times negative 2.3 is negative 8.05. W equals negative 8.05. Makes sense. Different sign's negative. Let's check that. Is negative 2.3 equal to negative 8.05 divided by 3.5? I don't know. Let's type it in and see. There you go. Negative 8.05 divided by 3.5 is equal to negative 2.3. Checks out. We solved it correctly. Okay, number 18 is weird. A lot of students look at this and go, wait, okay, I see the variable, but there's nothing with it. There's just a negative. What's that negative? I'm going to rewrite this. Ready? 16 equals. Isn't that really negative 1a? There's a negative 1 there. And if it's stuck to the variable, that means it's being multiplied. And if they're multiplying it, I'm going to do the inverse and divide it. Divide that side by negative 1, divide that side by negative 1. This turns to positive 1, which is what I wanted. Negative 16 equals a, so a equals negative 16. Let's plug it in and see if that makes sense. 16 equals negative 16. What does the double negative do? Oh, it makes a positive. Checks out. That was complicated with the signs, but it works. All right, get out a piece of paper. Watch the video to help you with the first few questions on your Canvas quiz. And now you are trying solving equations with multiplication and division, turning things into 1.